In this video, I'm going to review the example problem relating to the mole, and hopefully you've had an opportunity to try this already. So the question is, how many silver atoms are in an 85-gram silver bracelet? So what I know is that I have an 85-gram silver bracelet. What I want to know is how many atoms do I actually have? So my starting point for this is 85.0 grams of silver. So silver is Ag. And I want to end up with some sort of value that has units of atoms of silver. And I need to convert my way there, and I'm not sure how many it's going to take. So I'm going to start by trying to pull out information that I know I can use, because this problem looks simple, but there's a lot of hidden information that's not actually written out. For one thing, I can look at the periodic table, which always provides me one conversion factor, my molar mass. So the molar mass of silver is equal to 107.87 grams per mole. Especially if conversions are tricky, I recommend rewriting this as an equality for a conversion factor, that 107.87 grams will equal 1 mole of silver. I can pull out a few other conversions. Let's start with Avogadro's number, 6.02 times 10 to the 23rd things. So in this case, those things will be silver atoms, will equal 1 mole. Let's give this a try now. I know I want to end up, no matter what, in units of atoms. So I put that on the top of my last conversion factor. And I know that no matter what, I want to get rid of my units of grams. So I put that on the bottom of my first conversion factor. Now, if I do this, I do have a conversion factor that has grams in it. It's that molar mass. So I know I can go from the mass to the number of moles of silver atoms that I have. Now, looking at the atoms, I also have that in a conversion factor. It's over here in my Avogadro's number conversion factor. So I can relate atoms to moles. Now, looking at this, just using these two conversion factors, I can see that my grams will cancel. Sorry, wrong G. The grams will cancel. My moles will be on the top and the bottom of my fraction, so those will cancel, and I'll have just units of atoms left over. So now I'm going to come in and just plug in my numeric values. In 1 mole of silver atoms, it's going to weigh 107.87 grams. And in 1 mole of silver, I'm going to have 6.02 times 10 to the 23rd atoms. Now I can go ahead and I can actually plug this into my calculator, which will look like, if I'm actually just plugging in 85.0 times 6.02 times 10 to the 23rd divided by 107.87. And I could write out my units as grams times moles times atoms divided by grams times moles. And this is where we see those cancellations. And if I plug this into my calculator, which will require a little bit of work to manage the exponent, and let me know if you need help with that, but this will equal 4.74 times 10 to the 23rd atoms. So a big number. But we only really needed to use 2 conversion factors. We did have to remember one, and the other we had to make up from the periodic table, which can be a little tricky, especially when you're looking at a blank page. It's like, well, where do I start? That's why I recommend leaning on dimensional analysis, because I think, if nothing else, it gives you a very strong place to start from.